divided by a binomial. Now, I've got a waste question in mind that I was looking at, and how far could they go with this? Can they go a binomial on a straight line? Can they go a straight line? Yes, we've been doing that sort of stuff. But that's different. What if I had a cubic on a cubic? So let's for a moment get rid of all this stuff. Hey, well, let's just do it. Hey, I'll make all that too. Rather fix it up. Let's make the top. Now, I've got to think careful about what I do for this. I'm going to make these all negatives for a reason. That's why I'm going to do it first. Let's make that 2. Oh, guys, if you could see the thinking I've done about what numbers to make this or more. On the top, I want it to be x minus 3. Excuse my slow typing. X minus 4. Just get rid of those, because we don't want those anymore. I want them there for later though. So what do we got? What does the top give us?
Your x-intercepts.
Yeah. What does the bottom give us?
Your vertical asymptotes.
Yeah, and I'm writing all these in factorised form. So we know it's going to have a vertical asymptote at 2 and at 6.
Mm-hmm.
What's the reasoning for that? If we let that equal 0, we let that equal 0, that gives us 2 and 6. So in other words, I'm going to put in an asymptote there at 2. Or do I need to do it? Or is it really obvious that's at 2 and 6? Top. The roots are at, just like normal everyday factorisation. If I let that equal 0, when I times both sides by that disappears. And you're left with x minus 3 equals 0 or x minus 4 equals 0. So the roots are 3 or 4. Go back to what we did a moment ago. What's the leading coefficient if I had that expanded out as x squared minus 7x plus 12?
1.
Yeah, x squared minus 8x. Oh, it happened to be both plus 12, which is interesting. That causes some possible complications. So leading coefficients are 1 over 1. So by the way, if I made that a big value like 10, even 100, 10 even does it. Made it 100, what happens to the top?
It's way bigger.
Really big. So that gets really big, but this gets really big at about the same rate. So this amount, these amounts over here become insignificant. Because if I put 100 in there, 100 by 100 is 10,000. But you're only subtracting 700. So that becomes 10,000, and I'm only subtracting. So they're not that significant. And if I wanted to show they're less significant, if I put 1,000 in there, I'd have 1,000,000 minus. So, you know, if I bothered to write it, let's bother to write it for a moment. 1,000,000 minus 7,000 plus 12, whereas the bottom will be 1,000,000. Did you take that in before, Ash?
Sorry?
Have you taken all that item in before?
Yes.
8,000 plus 12. And then you can talk about which one's bigger. Is the top bigger or the bottom bigger?
Top is.
We're only minusing 7,000, but here we're minusing 8,000. So the top bigger, so we're approaching.
Yeah, I said the top.
Yeah. So x
What are you
approaches.
talking about?
As x approaches infinity, y approaches
1.
1. Because that's 1 over 1, which is 1. But it approaches it from the positive. And of course, if we go x to negative infinity, guys, there's so much more to come. This approaches 1 from underneath. No, it doesn't, does it? It's easy to think that because we're used to thinking by hyperbolas. Where does it approach it from? You can see on the graph it's approaching from the positive.
That looks like it's going past 1.
Looks like what?
It looks like it's almost going past 1. On the
I think that's because the decimals would be so small.
Yeah, so we'll have a look at that for a second if you want the time on it. Spend the time on it. So what have I got? I've got x equals 2. I'm going to put them all in for a moment. I'm going to make it next one. X equals
6.
Thank you. What's the next one going to be?
Y equals 1.
Yeah. So we need to find out where that intersects, because that's all the red, where it intersects with the, is that blue or purple or mauve or something like that? We need to find out where those two intersect. So what do we got? I could just leave it as brackets, x minus 3 by x minus 4 over x minus 2 by x minus 6. Where does that equal 1? Now where some of the weirdo stuff happens, where we get our brains to connect and think about this stuff. Let's see what this will like. So if I times both sides by that, I've got, I'm going to write it now as x squared minus 7x plus 12 will equal what? So I times this side by x minus 2, x minus 6, and I times that side by x minus 2, x minus 6. And I've got x squared minus 8x plus 12. They're going to cancel. X is over to here, I've got x equals, and I subtract 12 from each side, x equals 0. Go wait a minute.
But you could picture that either way, because if you just put them in the fraction, expand them, you'd see that they both have a 12 as your what's the word? Doesn't have a
How do you put on words?
Doesn't have a variable, so you just go chucking 0 there.
So then I'll do this here, and I go 7. And I go, okay, what's happening now? So now I got x squared minus 7x plus 12 equals x squared minus 9x plus 14. And I got 2x equals 2 and I got x equals 1. So yes, you can always find out that point B. How? By letting the red line equal the horizontal line, just like we've always done. So nothing's changed there. Now here's the big part, ready? This is something that took a while to sink in on my brain. I've deliberately made that a smaller and a bigger, and I've deliberately made those two in between those two. So the 3 and the 4 are in between the 2 and the 7. Now the syllabus doesn't even allude to this. So what if I make one of them bigger, like say an 8, let's go an 8. Ready for it? I can go, oh crap.
What's happening next door?
So I'll go back, drama. Go back to the 6. So what if I go to 6.9? Let's go. What does it have in the middle section? Now I've got to change, I'll have to change that to 6.9. Let's do that first of all. So what's it got in the middle section? Not 6.9, 7. There we go.
67?
That was a good one. So the middle section has a max. Of course, if I make a negative of it all, what happens to it?
Yeah, that's.
Then it has a min.
Looks like a guy got the emoji going.
So what if I go to 7.1? So this is where I can put sliders in and go with sliders. Of course, we're using decimals, so then no one
That's
can do that.
67.1 again.
Keep doing that. I told myself at home to stop doing that. The moment I went, one of them was larger than the 7. So what if I made it a 10?
71 again.
Hey, stop it! If I made that a 10. So now we don't have a max or a min in the middle.
What if you made both of them bigger?
Yeah, let's have a look at it. So let's go for, I don't want the numbers to be too extreme for a moment, so I'm going to bring that back to an 8. And I'll change that to a 1. Thanks, Lane. And we're back to one of those. But it's the upside down. What's this for a second? If I change that to a, so it's got a min,
Yeah.
change that to a 3 and a 7, a 3 and a 6, we're going to max. So here's what my brain's thinking about. If the 3 and the 6 are in between the 2 and the 7, and by the way, you can think of these as negatives and positives, you can go nuts. So I've made them all negatives, I could do it all on my own. With them all positives, I could do it all as a mixture. So if the two top ones are in between the two bottom ones, yeah, you got a max. If they're both outside, you got a min. But if I make one outside, this side instead of the other side, you know what's going to happen? you've got an asymptote. So I talk about when they're both outside or both inside, you have a turning point. And when you talk about, wait a minute, one's outside and one's in, what a word, how do I call it outside, inside? But they're actually outside the asymptotes. So that's what my brain's thinking of. The asymptotes are at 2 and 7. So I need one of the top values outside and the other side inside. Now, does it look like they intersect with the line y equals 1?
No.
What if I do this down?
Now,
Now they
Let's make it, maybe sometimes as you change these values to it can make it more obvious. 5, and say a 6, that might make it more obvious. Still not obvious, is it? I'll go over to here.
oh,
Yeah.
that's, yeah.
Does it cross?
no.
Go back over to here.
Does it?
Yeah, exactly. How far do you have to go for it to cross? Does that cross?
Doesn't look like it.
I go right here. So how can we test it without doing all this stuff? I can just zoom out for starters anyway. Does it go below?
No.
So what do I do to see if it goes above or below?
Make it equal 1.
Yeah. So it's no good hypothesising, we've got to be able to figure it out mathematically. And that's going to go all yet. I doubt I'm going to make a video out of this, guys. I just hope it's helping your brains. Might do it another day. Sometimes when I explain something like this the first time, I better do it again. So we've got x squared, pens. X squared, what have we got now on top?
Take 8x plus 15
Equals,
x squared, take 8x plus 12.
and it's annoying because these are going to cancel each other out. So what's what I'm going to do to make it different?
That means
Can you start to see there's a zoom in, not a zoom in, there's quite a few things for this. Let's go to 7 so they don't cancel each other out. Now it does go below. But where does it go? Where does it cross the horizontal? The horizontal line?
at 1 on the left.
But it doesn't cross on the right. Let's do it. So what do we got? Minus 9x, isn't it?
Yep.
Plus
12.
plus 14.
14, sorry.
So they cancel and you're left with x equals
1.
minus 1, isn't it?
Oh, that's one.
So if we go x is minus 1, it crosses there. But it doesn't cross on the other side, it only crosses on that side. So if they're both within the vertical asymptotes and they're outside the vertical asymptotes, one side will cross.
What?
One side will cross the horizontal asymptote. No, I don't know where it's from.
It's on the
Oh.
arrow screen.
Yeah, okay. I just touched it with my hand, didn't I?
Yeah.
If they're both inside the asymptotes, one will cross.
So we got 3 and 5. If they're both inside, one will cross.
And when do they not cross?
If the sum, the 3 and the 5, let's go back to this. If the minus 3 and the minus 5 equals the minus 2 and the minus 6, it doesn't cross.
Because they cancel each other.
Yes, if you write it as equal to 1. Now before I forget, I'm going to come back to that in a second. Let's go back to that being a 7. Let's go to that being a 2. 2 on top. Oh, we used using the wrong button. So what are we expecting the horizontal asymptote to be?
2.
2. And you can go through as x approaches infinity, as x approaches minus infinity and all that stuff. And it crosses again on the left. So let's go bigger again for a moment. If I made that 8, Go back to one of those. If I made it both outside of the vertical asymptotes, I mean I've got to get my words right. It's upside down. Interesting. So when you head in, you think, this is gonna kill me. I'm not gonna remember all of this.
Do we need to remember all of this?
Yes. So what's that one there? I've gone inside again. Let's make it 3 and 4. What if I make it 2 and 3? I'm going to do them in logical order. I'm going to change both of them all so it makes it more obvious.
Well, that's just one of them cancels out. So
Yes, and we're stuck.
with a
We're not stuffed, are we? We're back to a,
hyperbola.
yeah. So if I make that 2.5,
It's an ugly look.
What are those grey circles?
they're the turning point, the stationary points, and the X and Y intercepts,
And min and max.
and the intersection of any lines.
Oh yeah.
So if I go back out here, you go. The trouble is that it only copes with so far with those. But let's get this to a 3 again and make it more obvious. And get that to let's make it a 5. So 3 and 5 adds up to 8, 2 and 7 adds up to 9. So that's not going to cancel each other out in solving the equations. So what have I got now? Zoom in. So really the whole point of what I'm saying to you is, let's take that now with the 2 and go, what happens? What happens here? I'm going to write it over here. So if I had 2 outside of x squared minus 8x plus 15, and I had outside of x squared minus 9x plus 14 equals what value? We want the red to equal the, can you tell me what that colour is, please?
Blue.
Blue, say blue. For the red to equal the blue.
Colour 2.
So now we've got that there, and what happens with the 2's? They cancel each other out. Which is interesting if you write it like this. 2x squared minus 16x plus 30. 2x squared minus 18x plus 28. They cancel each other out. So how many points of intersection do we have again? Between the, what do you call it? The muttered hyperbola, the extended hyperbola, the double hyperbola with a thing in the middle.
What is it? What would we call it?
Yeah, it's got to have a name. So if I add a in x, I've got 2x, and if I subtract that, I've got minus 2, and I've got x equals minus 1 still. So what effect did the 2 have?
Just raised it up.
That's all I did. If I made it stupid and I made it a 5, there's a 5 will show out here, x is 5, and I'd have to go y equals 5. I mean, I said x equals 5. The y, the leading coefficient's 5. We got it 5. Intersection on one side. So again, if I made that, say a 10, we go back to that again. So I could go nuts, and I can go, let's make this one x minus 4, let's make this one x plus 3. So where's your asymptotes? 4 and?
4 minus 3.
Thank you. Now if we make the top ones in between, see if we know this a bit, that might not help a bit. See your asymptotes. We make the ones, let's make it x minus, let's leave it as x minus 3. Let's make it x plus 5. So I've got one outside, one inside? Sure. What happened again? We get an inflection instead of a maximum. How do you solve that mathematically, the C? Let's do it. Come on, let's do it. Your brain is switched off, you've had enough, okay? So that's an x squared minus, oh, what is it, plus a 2x minus 15, am I right?
Yes.
What's this one?
X squared, take x plus, take 12.
Take 12, yeah, sorry, I started looking at the graph and thinking about
I
that.
said plus and then take, so.
Yeah, and I started looking away in between.
Um,
So, I've got to change that back to where? Numbers are 5 anymore, do I?
1.
2 or 1.
3x equals 3.
Y equals 1. And they go, they do intersect, they have to intersect. Because if the middle's like a munted cubic, is it a cubic?
No,
Sort of takes a similar form to a cubic,
but it's not.
not a cubic. And so what do I end up with? They cancel each other out and I've got 3x equals 3 and x equals 1. That's
See,
not always going to be 1, is it?
That doesn't have a inflection like a cubic does. Like it doesn't.
Somewhere along that line, it'll go from concave up
Oh, I guess yeah.
to concave down. So there will be an inflection point there. Now, here's the interesting part if you go on and on. I would expect that inflection point, would it be halfway between those two?
Yes.
And how would you check? Differentiate lambda equals 0. You could differentiate that in your calculator, lambda equals 0, and see what it comes up with. So you wouldn't even have to do it yourself. You know, for us with a class pad. Now we keep on getting a 1, and I don't want to keep getting a 1. So how do I make it not be a 1?
2 or something on top. Or on the bottom.
Yeah. Well, if I make that bottom one down there, that one bottom down there, let's make that, say, 7. Now it's a minus 1. You see it? What if I make it an 8? Minus 1 a bit. What if I make it a 10? How do you get it? Go back to that one there. Let's do it. I've got, here we go again. Say it for me, Josh. X squared plus.
Sorry. X squared plus 2 take 15.
Yeah.
X squared take 7 plus no take 30.
Thank you. Cancels out. I've got 9x equals.
15.
I'm going to bother from that.
45. Sorry. 9x equals 45.
No.
No, negative 15.
So now x is minus 15 on 9,
Wait.
which is minus 5 on 3.
Yeah.
So it doesn't matter how yucky they give you, as long as you go, you know, make that equal, in this case 1. So if I put a 2 up here, I'd have it equaling 2, but it won't make any difference because the 2's will cancel. So that's moved it to minus 5 on 3. So could that do, they do that to you in the weights? Absolutely. Technically, they could make it a cubic on a cubic.
I hate the thought of that.
Well, let's just do one for the heck of it. Just, I didn't bother myself in the holidays. Okay? I got to the point and I said, no, they're not going to do that to you. Let's make that a 7. And Josh is going to sleep, poor boy. And I don't want them to cancel, so I don't want any factor on the top to be the same as the factor on the bottom. So let's go x plus 8. Imagine the possibilities.
What the heck?
So let's put our asymptotes in. I've got an asymptote. Let's make that 10 not so revolting. Let's go, say, 5. Oops, I hit 6. So I need an x equals 5. I've got 8 hit 6. That's where I get my rush. I've got a minus 3 and I want a minus 8, don't I?
That's why.
That's fine.
Oh yeah, thank you. X equals minus 8. But will it go as far as cubics? And then you can start looking at why did one have an inflection and why did one have a maximum? Couldn't you? We've still got the two two hyperbolic sections, a maximum section and an inflection section. So technically that could be an exam. I can't seem to like that. Or if I get rid of one of the bottom ones. technically this could be an exam too. You go, what happened? Where's my graph?
Whoa.
You know, we did partial fractions and you'd end up with a Greek asymptote. No, if you can remember that.
Yeah.
So if I got rid of on the top,
Oh, the whole thing.
oh,
Control Z. Or that.
Thank goodness.
oh my goodness. So if I got rid of that one, we're back to what we did in get rid of that one. We're back to what we did in your, I think your first investigation last year.
No, the second one.
Second one, thank you. And you got an oblique asymptote. Could you guess what the oblique asymptote was? Looks like it's going up to 45 degrees. We can calculate it, but I don't want to calculate for a minute. Looks like it goes through about 12. So wait a minute, let's get rid of that extra asymptote. Which one's that? That's that one, isn't it?
Mm-hmm.
Let's go. Y equals x plus 12. Too
You
big.
forgot the Y. Oh, wait.
Don't need it.
We don't need it.
And then do it for x. The way the thing's written. So I'll say about 9. No. About 6. Is that it? No.
No.
Probably 7. There we go.
Yeah.
You can do it by experimenting, especially when you've got the graphics thing like this.
Mm.
So that's when we had a binomial on top of a straight line, harmonic. Yeah?
Yeah.
So interesting part is the cubic on top of the binomial is basically the same as that, but extended. You see that in your head already?
No.
Yeah. So if I put on the top here, x plus 7. How's your brain going, Ash? You had enough and I'm going too far.
No, I've written all this stuff down before. I wrote it down ages ago.
Oh, you did?
Yeah,
Well, I'm impressed.
but I didn't have this
Wow.
much.
Do that. So what do we just added in? An extra section in it.
Mm. The not so cubic. in the
Yeah.
middle.
Yeah, I'm going to make these smaller so it's not so. So the bigger the numbers, of course, the bigger the scale. Yeah, that's a bit more obvious. I'll make that even a 4.
Yeah, so
So
all I've written down is for stuff like this, if it's y equals x squared minus 4 on x take 1,
yeah,
then you can separate that into x terms.
you can do a polynomial long division, or
Yeah,
you can
and
do
then-
the fiddling around.
Yeah, and then that gets you x plus 1 outside of another thing, and then you dominant power that,
Yeah,
and then that as x tends to positive or negative infinity,
yeah.
y tends to x plus 1 in this case.
You can see. So basically now, even though you
Oh, my
guys
eyes.
might, you guys might think, hey, that's a lot, but no, it's not a lot.